Okay, so we're heading into a unit on functions, and the first thing we need to do is just do an overview of functions. A lot of this should be review, but pull out the worksheet that you got today in class, and let's go ahead and start filling these notes in. Function. The definition of a function is, need a pen, for each input there is only one output. That means X can only be matched with Y one time. X can't repeat. There are some definitions in the upper left corner of this worksheet. There are 4 definitions that you need to know going forward with these. Domain is the set of all input or X values. Range is the set of all output or Y values. Independent is the variable associated with X. And dependent is the variable associated with Y. The dependent variable is dependent on something else. Break up this video a little with a funny little cartoon. Hope you enjoy it. Just thought I'd throw it in there. So let's look at the upper right corner of your worksheet here, and this is just a whole bunch of different ways that I can put an input and an output together. This is just an ordered pair. I can just put ordered pairs together, and if I look at that, I look and see that every X goes to a different Y. There's not an X that repeats, so this would be a function. Okay? This is a listing of a domain and range, but you'll see that my domain repeats. Remember, domain is the X values. My domain repeats. I cannot have a repeat in the domain, so this would not be a function. Looking over here at a table, this is bars sold, so if I sell candy bars, this is how much profit I will make. Okay, notice my Y repeats, but no X goes to a different Y. So this one over here would be a function. Let's look at the next table. Number of students, 24 students, 33, 28 students, 42, 28 students, 33. This 28X goes to 2 different Y's, so this would not be a function. And lastly, this guy down here is called a mapping. So this is a mapping. Okay, it maps an X to a Y. So if I follow the line from 0, it goes to 1. But notice there's also a line from 0 that goes to 4. The left one stands for the X values, or the input. The Y values are on the right, or also called the output. So if I follow my rule, this 0 maps to 1, which would create the ordered pair 0, 1, but it also maps to 4, which would create the ordered pair 0, 4. Therefore, this would not be a function. So when telling from a graph what is a function, we use what's called the vertical line test. If I can put a vertical line anywhere on the graph and not cross it more than once, it is a function. Why does that work? Well, here's my x. I use it here for 4, and I use it here for -4. So I hit this twice, which means it would not be a function. So the last one is, can I put a vertical line through and hit any of these points twice? No. So this would be a function. As soon as I add a point here, then it would not be a function. And lastly, let's look at the bottom right where it talks about verbal representation. This is probably the hardest corner, so let's just talk about this. The amount of money I make depends on how many hours I work. So we've been talking about independent and dependent, and this is what we're going to be working on in class tomorrow. Dependent and independent variables. So something in here depends on something else. And if you see what it says here, it says the amount of money I make depends. It is depending on how many hours I work. So the dependent variable we said was the y, and the independent variable we said was the x. So I would make a table of hours and money. And I would say, okay, if I work 1 hour, I get $12. If I work 2 hours, I get $24. Yes, this is going to be a function. I will never say I'm going to work 2 hours and get $26 also. It just doesn't work like that. Okay, let's look at the next one. The number of blueberries picked determines how many cakes are made. Well, here we used a different word. I didn't use depends on. So let's figure it out. Do the number of blueberries picked depend on the cakes, or do the cakes depend on the blueberries? The cakes are really dependent on how many blueberries I pick. So my cakes are depending on the number of blueberries I pick. So this would be my x, and this would be my y. And again, I'm going to go over here and I'm going to make another table. You can make these tables on the back and call this number 1, number 2 would go here. And so my x is the blueberries picked, the number picked, and the other one are the cakes. So if I pick 2 cups of blueberries, I get to make 1 cake. But if I pick 4 cups, I get to make 2 cakes. Okay, I'll never say if I pick 4 cups, I'll get to make 3 cakes, because I can't do that. So this would be a function. There would not be a repeat. The height of the students in Mrs. Irwin's class depends on their age. Okay, well, the height of the students in Mrs. Irwin's class is the one doing the depending on the age, x, and I already have a green y there, so that green y goes there too. We'll call this example number 3. So my third table, I would make an x and a y, and I say age and height. All right, so let's say some of you are 17 and you're 5'2", and I have a 17-year-old that's 5'8", and I might have an 18-year-old that's 6 foot. Would I ever have a 17-year-old that is a different height? Let's say 5'9". Well, of course I would. So because of this, because of the repeat, a 17-year-old can be 5'2", a 17-year-old can be 5'8", a 17-year-old can be 5'9". Your x cannot repeat to a different y. So this would be an example of something that wasn't a function. Number 4, the amount of money I spend at Starbucks is a function of how many drinks I buy. So again, don't use the word depends on, even though I just did. The amount of money I spend at Starbucks depends on how many drinks I buy, or do the drinks depend on how much money I spend? Well, obviously, the amount of money I spend at Starbucks depends on how many drinks I buy. I spend a lot of money if I buy a lot of drinks. I spend a smaller amount of a lot of money if I buy less drinks. So this is x. So we're going to call this example 4. And we're going to again make a table to see if this is a function or not. So the money I spend depends on the number of drinks. Okay? So let's see. I buy 1 drink, I spend $5. I buy 2 drinks, I spend $10. I buy 2 drinks. Well, I could buy 2 drinks and it could be, I don't know, $7.50 because I bought a small drink. So again, this, because of the repeat, this would not be a function. Now, if all the drinks were the same amount, yes, I had to buy 2 drinks for 10, 3 drinks for 15, but all the drinks at Starbucks aren't the same amount. So I could go in at $2 and spend a different amount of money as if someone else goes in and buys 2. All right, the last one. Teachers' ages depends on the number of students in their class. Okay, so we're saying that teachers' ages depend on the number of students in their class. Let's make a table for this. We'll put ages and the number of students. Well, I think I have 22 kids in my Algebra 2 class, and I'm 29. But I'll say Coach McNeely has 22 kids in his class, and he's got to be at least 70. And Miss Bauer could have 22 kids in her class, but she's only 32. So you can see that there's a repeat here, that the number of kids in my classes could go to a different age every time. So again, this would not be a function.